Good morning, everyone. Thank you very much for taking your time out of your busy schedule to join our Shape New World Symposium. This symposium is being held under the theme of what kind of future we'd like to choose, act upon, and leave behind, in conjunction with Expo 2025 Osaka, Kansai, Japan. It is a part of the theme weeks organized to create the future society together with people from all over the world, including you. This program features English sessions primarily organized by members of the World Economic Forum's Global Shapers community, as well as Japanese sessions led by Osaka University and JST and so many young academic researchers. Today, we prepared an enriching lineup of programs, including this morning session, Shape the Future of Healthcare Technologies, Navigating and Overcoming 2050's Challenges. We hope that you will actively participate until the end of this session, and hopefully you'll join the evening sessions too. We'd like to express our heartfelt gratitude to Masaru Ishikawa, the producer of the Osaka Kansai Expo, and also the Japan Association for the 2025 World Exposition and World Economic Forum, and the Osaka Chamber of Commerce and Industry. Thank you so much for your great help. And we have different partners in the research project: Social Solution Initiative, Osaka University, Research Institute of Science and Technology for Society. And we'd like to great thanks to MUIC Kansai、一般社団法人関西イノベーションセンターの皆様に多大なご協賛に心より感謝申し上げます。We'd like to thank for the generous sponsorship. And also, we are sponsored by so many companies in Osaka. We'd like to say a great thanks for these companies. I'd like to say in Japanese. サントリーホールディングス株式会社様、株式会社りそな銀行様、大和ハウス工業株式会社様、大阪ガス株式会社様、株式会社ユニオン様、近鉄グループホールディングス株式会社様、岩谷産業株式会社様、国用株式会社様、株式会社広瀬製作所様にご協賛をいただいております。また本日ご来賓といたしまして、大阪商工会議所副会頭の立野様にお越しいただいておりまして、ご挨拶をいただきたいと思っております。Today, Director Tateno is joining from the Osaka Chamber of Industry and Commerce, so we'd like to have his message at first. こちらお上がりください。
皆さんこんにちは。大阪商工会議所の立野です。大阪商工会議所では2024年1月からシェイプニューワールドイニシアティブの皆さんと共に地球的規模の課題解決に向けて議論するために準備してまいりました。本日はこれからの時代に欠かせないヘルスケアの在り方をテーマに議論いただきます。私たちの社会は技術の進歩とともに大きく変化し続けています。近年では健康に関する情報も数値やデータとして把握できるようになりました。またスマートウォッチなどを活用して日々の体調を管理することも一般的になりつつあります。一方でこうしたデータの取り扱いや その後の活用の在り方については、依然として検討すべき課題が多く残されています。本日はそうした課題について、若い皆さんがここ大阪の地で自由かつ率直に意見を交わし、世界の未来を切り開くきっかけを作っていただきたいと思います。よろしくお願いをいたします。ありがとうございました。
ご挨拶いただきありがとうございました。Thank you so much for your great comment for joining our activity to shape the new world. Now we are excited to officially begin today's session. So this session's title is Shape the Future of Healthcare Technologies, Navigating and Overcoming 2050's Challenges. So I would like to invite the moderator, Sora Matsumoto, to join the session. Thank you so much. 拍手でお迎えください。
Thank you for the introduction. Good morning. Thanks for joining us. Welcome to the session about healthcare technologies, where we discuss what we want to achieve in 2050 and how to approach those goals with the amazing panelists we have today. I'm Sora Matsumoto, and I will moderate this session today. I did my bachelor, a little bit about myself. I did my bachelor and master in Kyoto University, and most of my research experience is in Center for iPS Research and Application, which inspired me to be aware of the cutting-edge therapies and biotechnologies. I am now passing my PhD in European Molecular Biology Laboratory in Germany. So I'm not really an expert about healthcare or technologies, but I have a little more knowledge about general biology or biotechnologies. So I want to be a bridge between the panelists today and the general public. Although I'm not sure if I need to do it, because I also know that the panelists today are really good science communicators too. So without further ado, let me introduce today's panelist. Elise Jenkins is a co-founder and CTO of Coherence, formerly known as OptBio, and where she is innovating cancer treatment using brain-computer interface in the implantable chip. And Emily Lediter is a co-founder and CEO of Sunfire Neuroscience, and her focus is on improving women's health with wearable device, which is actually on market already, which is super cool, to alleviate the premenstrual syndrome, or PMS, and menstrual pain. And Jack Chen is a co-founded PointFit Technology, where he's developing the device that you can put on your skin to monitor the chemicals like lactate levels in your sweat real time. And he also co-founded Moonlab to make blockchain more available for society. And Jiani Zhen is pioneering a people sensing platform combining AI and body heat sensing technology in biotechnology as a co-founder and chief product officer. So we will have a short presentation from each of the panelists today to get to know who they are and what they are doing. And then we will move on to the discussion. This is the thing. So we want to use a platform called Slido, where you can post the questions, and you can also vote for the questions, so that the questions that are popular are asked with priority. So you can ask anytime during the session, and we will read it out at the end or after the open discussion. And yeah, and I will also show this QR code, and so you can either read the QR code or go to the slido.com and enter this code to join. And yeah, the one thing is that I want you to use your favorite AI tools to translate questions into English. Otherwise, I have to rely on my own biological neural network to translate Japanese to English, so I don't want to risk it. And yeah, so I think that's it before going to the presentation. So Elise, you want to start?
Sure. So good morning. Ohayou gozaimasu. My name is Elise. I'm the co-founder and CTO of Coherence Neuro. We are a startup based out of Cambridge in the UK, and we design next-generation therapeutic neurotechnologies. Could you go to the next slide? A little bit about my background. So I grew up in the Gold Coast in Australia, where I studied electrical engineering at Griffith University. I then moved to the UK in 2017, and I worked at Siemens for a number of years in the product team. After trying to find where I could have the most impact, I decided to go back to academia and pursue a PhD in bioelectronics and neuro-oncology at Cambridge University. And this is where I sort of discovered this really innate clinical unmet need in cancer. And so looking at how we could use implantable devices, electronics, to understand cancer and potentially develop new treatments for cancer. In particular, I was focused on brain tumors, glioblastoma, a really horrible form of brain tumor. During my PhD, I met my co-founder, Ben, who was in the lab just across the bench from me, and we kind of came together to form Coherence, which is what I'm going to talk a little bit about today. Could you go to the next slide? Thank you. And so at Coherence, we designed therapeutic neurotechnologies that manage cancer from inside the body. We really work at the intersection of cancer and neuroscience. This is an incredible field. Cancer neuroscience is about 5 to 10 years old, and essentially where we take the decades of understanding and tools that we've used in neuroscience and we apply them to cancer. So we take electrical tools and we say, how can we use these tools to understand the electrical properties of cancer? And what will that mean for diagnosing, prognosing, and potentially treating cancer? Next slide. And so in late 2022, my co-founder and I came together to build Coherence and raise our pre-seed round to develop Soma-1. This is a first-of-its-kind brain implant. It's implantable, fully wireless, and the first implant, to our knowledge, to be developed to be fully MRI invisible, so fully compatible with standard of care of MRI. This implant sits just under the skull, and it has a number of thin film electrodes, so really thin, flexible electrodes that actually go deep into the brain that can either record electrical signatures, or monitor how the brain is sending electrical signatures or messages, but we can also send electrical stimulation to modulate the behavior of those cells in the brain. And we apply this directly in cancer. And so we look at how can we measure the electrical signals that we know are changing in the brain as cancers progress and use that as a prognostic tool in cancer monitoring, but also how we can use electrical stimulation to modulate that behavior, try to slow it down, and try and target it. So that's something we've been working on for the last few years. Next slide. And we worked alongside clinical neurosurgeons to design this technology to be placed during existing tumor resection surgery. So this is part of the standard of care. And our system comprises of 3 parts. So we have an implant, which we call Soma. We have a wearable, which interacts with that device to power it, send messages, receive any information back from the brain. And then we have an application that a user can sort of control their therapy sessions and monitoring sessions. Next slide. And this is just to give you a very quick vision of sort of how we vision how we would use the Soma implant, or how a user would use Soma. And so after an overnight charge, a user would take off the wearable from the dock, place it behind their ear. They would then initiate a monitoring or therapy session. All of this is, all of the data is synced to their application. The user can input additional information like symptoms. That information is then remotely sent to their clinical team, so that doctors can look at how their disease is progressing, any intervention strategies they may need to implement. And then at any point, and most importantly, a user is always in control. So at any point, they can take the wearable off, continue living their sort of normal daily life. And therapy is always really on their time, as it should be. So next slide, please. Just a quick slide from us about sort of the traction and what we've done over the last 2.5 years. So we, bless you. So we built a first MVP of Soma. We were able to show with our collaborators at Stanford University for the first time that we could use electrical activity as a prognostic tool for how diseases progress through time. So rather than waiting 6 to 9 months for an MRI, we can see week-to-week variation in brain activity when there is a tumor present, and we can essentially see and track how that tumor is progressing through time. We also launched our second pipeline indication in pancreatic cancer, so applying the same technology that we use in the brain, but looking at peripheral nerves. We know that peripheral nerves innervating our organs are also very much responsible for controlling cancer progression and regulating cancer progression. We showed that Soma was safe when we implanted this in preclinical models. We worked incredibly hard with our surgery team to develop a clinical workflow to implant this in humans, and we're working towards our first in-human trial this year, which is very, very exciting. So I think I'll leave it there. There is a QR code on the next slide if you wish to go and have a look at our website. Very happy to be part of the panel, and thank you for listening.
Great. I'll jump in now on the theme of brain and neuroscience, and especially with a focus on the electrical activity in the brain. So I assume most of the audience here who have come are already familiar with the fact that brains can be, to some extent, manipulated using electrical energy. And Elise spoke about some aspects of it, and I'll be covering some of the non-invasive therapy angles here as well, with a specific use case of women's health. So we operate more at the intersection of women's health and neuroscience. Next slide, please. So about myself, I'm first and foremost a neuroscientist, born and raised in Lithuania, which is why my name has all the different dots. And then I went to Harvard for my undergraduate, where I studied neuroscience and anthropology, trying to understand where the interaction between the science and all of the technologies we develop is with our lived experience and different experiences and cultural needs that are necessary to adopt the technology at scale. And then I did my master's and PhD training in neuropsychiatry in Oxford. There I focused specifically on understanding how those technologies can be applied in the clinical field, so specifically for treatment and management of long-term and chronic conditions. What's also important about my background is I spent over 4 years working as an emergency medic and led Harvard's emergency medical service with over 90 practitioners. What that showed to me is that a lot of the work we do in the labs that is so forward-thinking, and all of the work that everyone on this panel is doing as well, really needs to be translated into everyday care. Because oftentimes when you go on the front lines, people don't have access to those technologies, and it's an incredibly limiting thing for us to be able to expand that technology into as many people as possible's hand. And that experience really illuminated that for me. And I'm the co-founder and CEO of Samfire, and prior to Samfire, I had founded an NGO focused on neuroscience education, because I think that everyone should have access to the knowledge of how powerful knowledge of the brain can be. Next slide. So even though when I started in the field of women's health and neuroscience, I thought neuroscience and neurotechnology would be the field that people know less about. But one of the things that I understood is that, weirdly, people have actually, who come to these talks, are quite well educated on the neuroscience and the neurotechnology, but a lot of them don't know anything about women's health. So I'll spend a few minutes just telling you a little bit about where we are at with the status quo on women's health. So women of reproductive age, so we're talking all of the women from about 12 years old to about 50 or so years old, currently are not getting the care they need. What do I mean by that? I mean specifically that the average out-of-pocket medical spend by women is always higher across their lifetime. So in this graph, you can see in green how much women spend on healthcare, and in blue how much men spend on healthcare. And you can see that at every single age, women outspend men. It means they're looking for something more than men on average. Let's go to next one. We also know that in the US, where health insurance can have kind of maximums, I don't exactly know how it works in Japan, women tend to top out their health insurance a lot more than men, which means they go to a lot more appointments and need a lot more care and follow-up. And even after they top it out, which means they've used the maximum that they can, they spend about $1,500 more every single year on these like additional expenses to manage whatever they're doing. So all of these expenses show that whatever care they're getting now isn't actually being met by the current system and treatments available there. Let's go to the next one. Secondly, pain and mood disorders are very common in women of reproductive age. In fact, 1 in 3 women, so if you look around, a third of the women in this room have at least one disorder that manifests with severe mood or pain symptoms. What do I mean by these symptoms? So if we look at pain disorders, examples could be things like endometriosis, uterine fibroids, chronic pelvic pain, migraines, and fibromyalgia. Those are very common pain disorders, and they disproportionately impact women. Some of them exclusively impact women. And then examples of mood disorders include PMS, or premenstrual syndrome, so feeling off the week before your period to a different degree. Then there's this condition called PMDD, premenstrual dysphoric disorder, where you feel essentially depressed for the 2 weeks before your period, and then you're totally fine. And then next month, you're depressed again for 2 weeks as well, which affects up to 8% of women of reproductive age. PCOS, polycystic ovarian syndrome, and postpartum depression, just being some examples of them. I bet some of you have heard some of these, many of you may have not, but the point is that they're very prevalent, and about a third of women are impacted by one of them to some extent. Let's go to the next one. So we just discussed that there's a lot of reproductive disorders, and I think over the last few years there's been a lot of narrative that it's women's hormones responsible for them. And obviously hormones have a play there, but actually the symptoms cannot be explained by hormones alone. If you look at most women's blood who have these symptoms, so symptoms of pain and mood, that actually their hormone levels are usually identical, but they have very different experiences. It doesn't explain the pain or the mood they're feeling. But what does explain it is the brain's sensitivity to that hormone change. So even though 2 women may have the exact same hormones, their brain might be responding to those hormone changes that are very natural and happen every month, every time you have a baby, as you're going through menopause. They change all the time, and our brains have different sensitivities that lead to these pain and mood disorders. Let's go to the next one. In pain disorders, more specifically, we see an elevation of what's called theta waves when you do an EEG measurement in the motor region of the brain, which leads to increased pain sensitivity. So we know that when your brain responds this way to hormones, you will be more sensitive to all kinds of pain, including chronic pain. And in mood disorders, we see a different pattern, which is that in the prefrontal cortex of your brain, so kind of around your forehead, we see an asymmetry of the alpha waves, and we know as a response you're not able to manage your emotions as effectively as you otherwise would. So these are real changes that can be observed in the brain, even for people with identical hormonal changes, that pretty much completely explain the differences in that pain sensitivity and mood control. And even though it seems straightforward that if all of this can be explained by brain activity, current women's health treatments completely ignore the brain. In fact, none of them target the brain at the moment. And we know that most patients currently find the treatments quite unsatisfactory. This is a quick graph to show you how much women's healthcare has changed over the last, 25 years now. And essentially what you should see here is that over time, the use of oral contraceptives and hormonal methods to manage symptoms has really decreased as women understood that just managing hormones alone doesn't solve their problems. On top of that, what this complex graph essentially tells you is actually pharma companies are not looking at these women's health issues because they're very hard to solve, because they're based in the brain, and we are really struggling with pharmacological treatments to impact the brain at its core. So it is increasingly clear that a solution needs to be in the brain, and therefore we built it. So we built a device called Nettle, which, as Sora mentioned, is now on the market in Europe and the UK, and we hope will be reaching the US later next year. It's a wearable headband that looks exactly like in the image there, and it is currently the only proprietary and patented non-invasive device. So non-invasive being that it goes on top of your head, unlike under the skull, like Elise's device. And it is certified for menstrual physical and mental health needs, so specifically for reducing pain and improving mood in women with period-related symptoms. Go to the next one. It's CE marked, so it's a medical grade device, so it can be prescribed as well as bought online for managing these symptoms. Let's go to the next one. And it manages these symptoms by targeting 2 brain regions. 1, the prefrontal cortex that I mentioned for mood, and 2, the motor cortex for pain, as we saw how it's linked to the mechanisms underlying the theory. The way you use it is literally 5 days before your period. You put it on top of your head, you use our app, you turn it on, it stimulates your brain, and then you take it off. Again, for us, control is paramount because we know how much the flexibility and the ability to adapt to people's routines is important, especially when using novel technology. These are some results from our clinical trials. I mean, we outperform everything that's currently on the market, mostly hormonal contraceptives for managing mood symptoms and antidepressants for managing premenstrual symptoms, as well as painkillers, so specifically non-steroidals for pain management during periods as well. And you can see the effects here. So the vast majority of people will see a response within a single month. These are some reviews. I highly recommend you read the experiences of people. I think for many of you, maybe me speaking about women's health today was very new. So I recommend you read online some of people's experiences about what it actually does to their life to not be able to plan around these symptoms. And I'm sure there's people in the audience who have lived with these disorders for all their life as well. We can skip that. So for us, really, the focus is on making custom-built solutions for something that is very prevalent. So unlike some solutions in neurotechnology that are for very dire but relatively rare circumstances, like glioblastoma, we try to cover things that are actually very common and currently don't have treatment options as well in order to improve accessibility to neurotechnology for everyone who could benefit and reduce side effects from current treatments while improving the treatment outcomes as well. Yeah, and that's it for me.
Thank you. Jack.
Sure. First of all, thanks for having me. It's really my pleasure to come to Osaka and do this panel discussion. I hope to learn from every panel here and then learn from the audience in front of me as well. So a little bit about myself. So I'm Jack. I'm one of the co-founders at Point V Technology Limited. We are actually a startup based in Hong Kong. And then me personally, I graduated from Hong Kong University of Science and Technology. So this startup was actually a spin-off from the university lab. It's actually a partnership between chemical engineering lab and also integrated system design lab, which is the lab I'm at. So I'm really a product engineer by training. So then I met my partner Kenny, which is my co-founder right now, and then we met at the same class. And then a little bit funny story about the project, right? So we were die-hard basketball fans, and then we love playing basketball so much. And then apart from playing the physical version of basketball, I mean actually playing basketball in the court, we also play video games. So I'm not sure any one of you guys heard 2K, which is the very famous basketball games from the Xbox. So we play that, and then in the game, there's a what we call energy bar, so that for each athlete or energy player, for each NBA players, like for example, I play LeBron quite a lot, and then one of the strengths of LeBron is actually he has pretty dense or very long energy bar, meaning that he has enough stamina to stay on the court for 4 quarters back to back, so without any rest and any. So what does the energy bar means? Meaning that if you are actually dropping your energy bar in the game, so that specific players, all types of performance will get affected. For example, I'm shooting very well in the first quarter, but then when it comes to final quarter, I'm shooting very poorly because of my stamina and my energy. And also it's very easy for us to get injured if your energy bar is dropping significantly. So then we think about, okay, in real world, we don't have that, right? So when me as a coach sitting at a sideline, I'm seeing, oh, okay, that's my players playing on court. I was like, okay, you're still doing fine. Just keep going, keep going. But then we don't really know, there's no scientific and visualizable approach to see that specific player's data. So then we think, okay, what if me and my partner Kenny think of what if we can actually bring the game into reality so that we have an energy bar in the real life. So can you go to the, so that's what I'm talking about. So on the left-hand side, what we are seeing right now is like the typical healthcare monitoring or tracking system is built based on electrical sensing, which is like, okay, you use like a Apple Watch, you use Samsung Watch, Xiaomi Watch. Basically, it's electrical sensing, right? So what the problem with that is like it's not so accurate. Basically, every type of sensing is done through a formula or algorithm so that they calculate that amount. It's not like from your body fluid or your body itself. It's not a biomarker tracking. And the second problem with that is like for example, when you use Apple Watch, then you see your heart rate goes quite fast, but then you don't know the underlying reason causing that. For example, your heart rate increase can be because of sports, can be because of drinking, can be because of smoking. So you don't really know. You know the result, but you don't know the underlying reason. Then we find out, okay, on the right-hand side is a typical, I would say, blood fluid testing, which is considered as more accurate. And the golden standard right now is through blood. So that's why when you want to get a very detailed and comprehensive test, you always go to the hospital and do a blood test, right? That's the gold standard. But the problem with blood tests is really painful, and it's very invasive, meaning that I need to actually prick your blood. And the second issue with blood testing is that it's really hard to access, right? So you have to send your blood sample to a lab, and then the lab will analyze it and give you a report in 2 days and stuff like that. And then it's non-continuous, meaning that I think it's really nearly impossible to keep drawing your blood, right? You might die. So then the problem with that is always get I would say time-stamped data point, which is not continuous. Can we go to the next slide? Yes. So this is our product. This is what we did right now. So we actually make a skin patch that is nano-level thickness so that you can stick on your body. It almost looks like a tattoo, right? But then it's very thin. It's actually 1,000 times thinner than your hair, so that it can actually stick on your skin without any adhesive. And then it's one-time use, and it basically collect your sweat, and then we evaporate most of the water, because 99% of your sweat is actually water. We evaporate it, and then the remaining 1% is basically different biomarkers of your body. So we currently track lactate, which is very useful for athletes, and then we also track cortisol, which is a stress indicator, and then we also track glucose. But then glucose, of course, is a medical grade product, so we're still in the process of filing FDA and all that. But then we potentially, scientifically, we in the lab already achieved that. But the lactate and the cortisol is already commercial products. We are selling in, I would say, Asian regions, Hong Kong, Singapore, China, and we also one of the strategic partner of ASICS as well. So we try to actually sponsor our devices to the Japanese professional athletes in Japan. Yeah. This is our product. This is how it looks right now. So we actually partner with ASICS. So what they want us to do is integrate our sensors with their existing fabrics design. For example, clothing, headband, this kind of basically different kind of fabrics they have. And then we on the left-hand side, you will see our sensor acting as a tattoo. And then you have a wire connect to a PCB, and it's connected to Bluetooth, so they can transmit real-time data to the coaches, which is having a mobile phone or iPad or different dashboard. So what we want to do is basically we get as much as data as possible for the coaches to make smarter decision for their athletes, because the athletes, they never know. Because in sports, like me, although I'm not a professional athlete, but then we always want to push our limit, right? Because the sports essentially is about pushing your limit. So today I can run 10 km. Tomorrow I want myself to be able to run 11 km. That's the progress you are trying to see. But then the problem with that is if you don't do it properly, you will get yourself injured, which a lot of times is quite bad for a professional athlete, because you rest 2 to 3 years and then you miss your entire golden age. Yeah, let's go to the next slide. So this is what we did in Paris, and then we did in Hong Kong quite a lot as well. So we work with professional athletes, and they wear our devices. And then on the other end, also do traditional blood testing, because in order to prove our device is accurate enough, we actually compare our data point with the blood test. So on the right-hand side, you see you see the diagram on this side. So the red dot is actually the blood test we did for the athlete. As you can see, it's timestamp based. So, but then on the if you see the green curve, is actually the data point we get from our sweat sensor. It's continuous, as I explained early on, because it's sweat. Even when we're sitting here, we're actually sweating. It's not like in the liquid format, but it's in vapor format. So we constantly sweating as a human being. And then, so it's as you can see on the graph, it's highly correlated. So actually right now, a little fun fact, as a professional athletes, on a typical training day, they do 11 blood tests. So basically every 1 waking hour, they do a blood test. It's quite painful for professional athlete, but they need the testing to get the lactate data so that they can know, okay, it's a good time for me to do sports. So the lactate data is a very important indicator to show your muscle fatigue. So if your lactate goes really, really high, as you can see, there's a spike, meaning that your lactate level spiking, you should consider stopping your training, because if not, you're pushing too much, you will very likely get injured. So that's what we do. We try to, before you spiking, we try to alert the athletes or the coaching staff to stop the training. Yeah, let's move on. So yeah, this is our training and different integration we did. Most of the people using ours are sportsmen right now, and they're in endurance sports, like they're running marathon and then are doing cycling, because endurance sports actually needs quite a lot lactate readings. So we can actually replace the traditional blood testing approach to make it more non-invasive and also continuous. Yeah. Let's move. Yeah, this is about us. If you want to know more, feel free to go to our website, and then we also have a Q&A session later on, so feel free to ask any questions. Thank you so much.
I will start the keynote.
Good morning, everyone. My name is Johnny Zhen, co-founder and chief product officer of Butler. And I just noticed that I'm the only one putting my name here as a big logo, not because I love myself so much. I thought we should not talk too much about the company and business. But anyways, I graduated from MIT 6 years ago, and then soon after, I co-founded Butler with a simple but powerful idea. What if we can track, actually, can you go back to the previous one? What if we can track people activity and space use, not through cameras, but through body heat? So we spun off from MIT Media Lab in 2019 from a research group focused on understanding people activity and environmental patterns using large-scale data. And with that foundation, we developed a privacy-first, scalable people sensing platform that consumes minimum computing power to generate powerful spatial insights. Next one, please. So unlike high-resolution cameras, our low-resolution thermal sensors do not see faces, identities, or visuals. So all we sense is temperature differences, and that's good enough to review people presence, movement, and also their activities. So we want to ensure privacy at the hardware level, not even in the post-processing or data processing. And all we sense is heat, and that simplicity allows us to build a solution which is affordable, scalable, and efficient for different kind of applications. Next one, thank you. We actually started our business in commercial real estate. So we help customers optimize space, reduce carbon footprint, and also improving safety. And over the past few years, we saw this critical opportunity in senior care. So we launched Butler Care, which is a dedicated platform for senior living and aging in place solutions. So again, unlike camera solutions, we use low resolution thermal data to track people movement and their locations we can also detect sleep patterns, bathroom visits, which are very critical indicators for UTI and other kind of health metrics. We also send real-time alert to caretakers of unusual activities such as fall, wandering, and changes in routine. And all of those can be built on top of our API, so integrate our data directly to their existing system. And this is our sensor. So our sensor can be mounted on the ceiling. It's a passive sensor, so you don't have to wear anything on your body. It just passively monitor your health data when you live inside. And so this ambient layer of health monitoring is invisible, is non-intrusive and intelligent. We believe this is the future of aging at home, and also having something you don't need to maintain a lot to keep your health data around you from your daily movement. Next one, please. So beyond that, we are also pushing the boundary of thermal sensing technology. So we are doing precise post-detection for fall detection using thermal data. And here you can see that we can detect that person is lying down in a spot which that person should not be lying down, and that's how we detect fall. So those advanced features will be available in our next generation product line. Next, please. So I think when we started the company, we have this vision that safety and privacy should not be trade-offs. We design for both. Our mission is to create a future that technology really cares for us quietly, respectfully, and intelligently. Thank you.
Thank you. Before going to the open discussion, maybe there's one quick question. So you've introduced kind of sensors. Do you aim they are given from hospitals by doctors, or should we buy them in shops as consumers, like exercising machines?
So yeah, so currently our business is B2B. As I mentioned before, we started from commercial real estate, so working with like big companies monitoring their occupancy in the office. We just started working on senior living use cases, and mostly we work with integrators. So again, a lot of communities, they already have like multiple technology they're using, and the caretakers, they're very like exhausted because every other month they need to get training on new technology. So how we sell to the customer is we sell our data and they can integrate from our API to their existing platform. So it's not a commercial product yet, but hopefully next generation product, we can make it as easy, like in terms of user experience, should be as easy as commercial product.
Great, thank you. スライド戻していただいてもよろしいでしょうか? Okay, maybe later I will show the QR code again, but maybe we can go to the, wait, thank you. So we have a QR code at the end, so please use this to enter the Slido. So maybe we can go to the open discussions about like what you want to achieve in your field by 2050, and what would be the obstacle that you have to overcome to do that. So I don't know who wants to start. Anyone volunteer? Please. Thank you.
Yeah, so I think for implantable technology specifically, right now, everything in healthcare is very reactive. So we wait until we have symptoms, we wait until disease is at a certain stage before we can implement some type of intervention or strategy. And that's very much the case for any type of implantable device. We're talking about a device that you need to surgically open someone up, put it in, and either manage their symptoms, treat their pain, disorder, whatever it might be, for a lot of diseases that have significant clinical unmet need, like cancer or paralysis or whatever it might be, Parkinson's disease. And so that's where we're at right now. And I think 2050, or the future of these technologies, what I hope for is to live in a world where we manage people that are healthy. So we have a way to measure people and monitor people before they get sick, before that they start having symptoms, and that these technologies can be miniaturized into a way that their risk of implantation is so low that it becomes mainstream, that people have these types of technologies. And my interest specifically is in health, but I know others from the neurotech space, and especially in the implantables, are really interested in pushing that next step in terms of augmentation. How can we go beyond the healthy state and go to that next point? And I think the barriers, there are a number of them. There are technical barriers, trying to get technology to be small enough, miniaturized enough, safe enough. Very big barriers in terms of regulatory and adoption. So I think there are a number of strategies that need to be implemented from a policy point of view to be able to regulate these technologies, and having the right people in place to understand how to regulate those technologies. And then there's a big ethical consideration. So who owns this data? What happens if a company closes down? Who's going to be responsible for making sure that the technology is upkept and the patients are still, or the people, I should say, are still monitored? So I think there's a number of barriers there, but I think the trajectory is looking very exciting for the field.
Yeah, I guess in a similar vein as well, and speaking more from the non-invasive space as well, I think on top of all the barriers that Elise has mentioned, I think there's a big societal barrier as well. I think what has been very interesting for me, like being in neuroscience for the last 10 years, is that we have accepted the way that most conditions can be managed with medication. In fact, when most people go to the doctor's office, they expect that, the doctor will maybe run some scans and then eventually will give you medication. But especially when it comes to brain health, and actually the vast majority of the conditions, the drugs you're given first are not really personalized to you. Like maybe there will be some dose calculation, but that's usually won't be adjusted if you're a woman, won't be adjusted if you've gone through menopause, won't be adjusted to your specific subtypes or how you might respond. So I think there's that lack of personalization. And I think the reason that's interesting is that whenever you take a medication, which, as I said, is now taken as standard, only a small fraction of the medication ends up in the place where you actually need it. So let's take an antidepressant, for example, or any drug that needs to act on the brain. 50% of it gets broken down in the stomach, so even before it goes into your circulation system, and then it floods your entire body system for only 2% of it to actually cross the blood-brain barrier, which is a problem because it means as you need to amp up your, let's say antidepressant dose, you have lots of systemic side effects, so you're impacting your entire body. Your entire body is struggling with the side effects of that medication, whereas only a fraction of it is actually doing the reason why you're actually taking it in the first place. So my perspective until 2050 is that we really need to shift to these ways of reaching the problem, especially medical issues at their core. And ideally, we can prevent them in advance, to that point of monitoring ahead. But when it comes to therapeutics, I really think we should be acting on the actual modality that we're trying to fix. If it's a brain issue, we should be acting directly on the brain and trying to impact the kind of peripheral effects as little as possible. And if it's a broader issue, like, for example, in Jack's case, like sensing overall strain, then we should be able to impact it at that location as well. So what I hope for by 2050 is that a lot of the technologies that we talk about today have become much earlier interventions where we're able to actually involve them early on in monitoring, in treatment, and therefore we don't need to advance further. And I think one of the main ideas I'd love to leave you with is that many of these may sound like quite interventional or quite intense technologies and so on, but the problem is that if you let an issue progress, you'll need a larger intervention. So the earlier we intervene, the less we need to intervene. So if we can adopt a lot of these technologies earlier in the course, like to prevent falls, to prevent overstrain, to improve women's health, to reduce the risk of developing cancer, I think that really changes our interaction with the healthcare system. And I think the biggest challenge for that will be the societal adaptation, the reimbursement systems, the payer systems, and how would we live in a society where most of us live healthy lives as opposed to need to go to healthcare to fix everything that goes on? I think it's an interesting question that I don't see a lot of discourse on because I think most people don't think that's realistic, but maybe by 2050 it will be.
Sorry, I didn't quite get the question. Are you asking like the vision of 2050 or?
Yes, so you want to achieve like vision.
Oh,
in your
okay.
field.
So, yeah, and the barriers. Okay, got it. So I think in general, our vision is to allow people to have a more data-driven approach to know about their health on a real-time basis. That's what we want to do in long term. So, and I don't think that will change. I think by 2050, people probably gonna get a very overwhelmed amount of data that will be presented to them, and then they probably is too much, too overwhelming that they cannot digest themselves. But then luckily we have AI, and I hope like AI will be more powerful by then. I'm pretty sure it will get to that stage. So AI can actually summarize different data points on behalf of the, I would say the user of ours, and then they can help them analyze the data and then tell them what kind of stuff they need to do to be healthier. Because I think everyone talk about healthier, and everyone wants to get healthier, but then without knowing what's wrong with yourself, it's nearly impossible to be healthier, right? What are you improving? So what we are trying to do is really have a very non-invasive approach so that people don't really feel anything, and they will be able to track their health on a real-time basis. That's what we think we will be able to achieve by 2050. If it's not us, it will be someone else. Someone will achieve that. And then the barriers, I think are really echoing with other panelists as mentioned. I think regulatory and compliance related issue are the hurdles we are facing even today, because a lot of time we are dealing with very sensitive personal data. It's not really PII anymore, right? It's really like your health data, especially for our company. We're dealing with your lactate, cortisol, and then your glucose, which is like very medical grade data point that we need to collect from the user. So we're talking with a lot of government, and then as a software engineering, the problem I'm having is like the regulators don't really know the technical stack we're using, so they have a lot of challenges about, for example, we said we did encryption, we did hashing, we did a lot of a privacy-driven approach to prevent people see the underlying data, but then the regulators are not essentially engineered by training. So I think we take a lot of lobbying to explain them what does that means for them to adopt what we are trying to do. So I think that's a big hurdle for any innovations in general, is to work with, try to make a product that is innovative, but then at the same time protecting the general public's interests. I think, yeah.
Thank you. Jenny?
I think I want to add on to what Jack just mentioned, because he talked about privacy, using data to help people analyze health conditions. I think my company is founded based on the fact that we want a solution which is privacy friendly. And we don't use camera for a reason. It's actually easier to use camera solutions. So I want to talk about like now and in the coming future years, how would we get those data to train our AI model to understand people's health condition or like behavior? And that's a critical part, because when you think about AI or like computer vision, everything is around camera solution. You have a self-driving car and you have multiple cameras radar there. You have a camera in like retail store to understand how people utilize the space and which aisle they visit most. You have a camera in the hospital to see if there's any unusual activities in the space. So I think what we want to do from now on, actually 5 years ago to now, is really to build a foundational model using thermal data to track people behavior and movement, and translating those data into health insights or like activity insights. So when I envision like in the coming years, maybe not 2050 that long, I think AI would change a lot of things. Maybe in 10 years we would reach to that point. We have a lot of data to process, but what I don't want to see, at least from my perspective, is all the data is built on personal data with camera resolution, knowing what you do exactly, and then get the solution. We want to build a system which is like embedded in your home, at your buildings, and invisibly, passively collect your data without violating privacy. So I think that's a course we are working on right now, which is actually much harder than I thought, because you can find a lot of like computer vision, camera-based footage to analyze people behavior online on research paper. But when it comes to non-RGB, low-resolution thermal data, you get very limited information from those data. But how you get precise action or insight from there, it's very difficult. That's what we spend a lot of time on, and hopefully we can continue that process.
Yeah, that's great. And yeah, I think the one thing that is common was about regulatory things. And I'm also aware that regulatory system is varies between different countries, right? So, and then some of you moved countries to develop the company. So I wondered how it works for you, or what would be the good way to start the new product, starting with easy, with less regulated countries, or and going to the other countries, or what do you guys have any ideas of how to start the more difficult, ethically difficult technologies, and going globally afterwards?
I can speak about our experience and maybe things we'd consider doing differently. So, as I mentioned earlier, we have a Class 2A medical device. So there's normally Class 1, Class 2, and then Class 3. And we first got certified in Europe. And when we were deciding between whether we want to get first certified in Europe or the US, the reputation that we heard is that European certifications were much harder because they had recently introduced this MDR regulation, which had much higher clinical standards, much higher quality control standards, and we were told that FDA is relatively easy. As a company at the time, we were based in London, and so we decided that with the EU regulations, one, it was more proximate and we could understand it better, but two, as a company philosophy, we wanted to do the hard thing first from a regulatory perspective, because we felt that if we do the harder regulation first, then it's going to be much easier to scale the others, as opposed to sometimes when you get your first clearance and it was very easy, then adding those additional quality layers as you go to higher or stricter regulatory environments can be difficult. So for us, because we have a global vision for a product, because it's something unique that no one else in the world does, we thought, let's do the hard thing first and then scale to the easier countries first. What we have learned since, after doing the European regulation successfully, is that I actually don't know if I accept the harder and easier nomenclature, and I'm keen to hear other people's experiences as well, because we just found as we started entering the US that it was really different. The things that matter to US regulators were just quite different from the things that matter to EU regulators, and we actually need to kind of do the process from scratch anyway. I mean, the good thing is that systems, for example, like Japan's, are quite similar to the CE marking and have pulled some things from the FDA, so there are some overlapping things, but at least from our experience doing EU and US, they care about absolutely different things, different types of evidence, vastly different ways of communicating it, and very different processes, people you need to know, and stuff like that. So I wish I knew earlier that it wasn't a complexity thing, it was like a focus thing and which one you need to do. So at least that was our experience. If we were to do it again, I think I would have tried to do a lot more of it in parallel and build those systems in parallel. And I think the reason we didn't is because we thought it was a complexity problem.
Interesting. Elise, do you want to start?
Yeah, I think I'll add to some of M's points. I think there's so much to unpack here, but one of the abilities or one of the advantages of being a startup is your ability to move very, very fast. And anyone who's tried to take any device through any form of regulation will understand that that process is not fast. And so when we were looking at, similar to M, when we were looking at where would we try to regulate first, we're based in the UK, the FDA, there's a bigger market. In the US, we actually looked in Japan, we looked in India, and Australia as different options. And what we were kind of looking for is essentially a path that had already been stepped through. So looking for regulatory agencies where people have already done something similar, like as a first in human sort of trial. And there weren't very many examples of this. And so when we were looking in the UK, we actually got very involved with the National Neurotechnology Regulation Framework to try and encourage the regulators in the UK to have a framework for implementing new innovations in neurotechnology. And for us, we're an active Class 3 implantable medical device. So the barriers are very, very high, as they should be, to protect people and make sure that the device is safe. But the long story short is we kind of went the opposite way. We need to get to people as quickly as possible for a number of reasons. To get to the patient as fast as we can. It's a much longer journey for an implantable device. But also, as a startup, you have to move fast in order to hit milestones and sort of get your next fundraising batch. And so for us, we then looked at the UK, the US, and Australia, and we saw that in Australia, in the clinical trial framework for first-in-human trials, was an incredibly well mapped path. They're very, very familiar with, and there were examples already of doing these sort of first-in-human trials with implantable brain devices. And so that stood out to us as a very attractive place to do that. Also, Australia is great to go to. If I say so myself. But so that's kind of the path that we've decided to go on, and how we kind of regulate in terms of the market is going to be our next step. So that's what we've done so far.
Great. One note for the audience who are asking questions. So maybe, or maybe not, people not asking questions, maybe you can vote the questions because it makes it easier for me to choose the one question. And the another thing is that maybe you can also, if you want to ask a specific person, you can also specify the person that you want to ask questions. And there are actually 4 questions already. Oh, 5. Okay. Yes. What is financing and strategy for running it? Okay, maybe I will prioritize more general one. Or Jack and Jenny, do you want to add something on the previous topic? You want? Sorry.
I can add something because I grew up in China, and 8 years ago I moved to America to study and then started my company. When it comes to camera solution, it's very different, like how people perceive the use of camera or like privacy-friendly devices. So in China, I think it's a norm that you have camera everywhere, and it's actually helping a lot of like reducing crime scenes rate and those kind of applications. So people get used to it, and I think. But when I moved to America, I think people really care a lot about privacy, and also European countries. And what I want to do is really to provide people options. So you can choose camera solution with critical application, like if you're in a hospital, the patient is in very critical condition, I think you need a camera to look after them. But in regular aging in place application, we wish to find something like less intrusive. And it's funny because when we started the startup, we tried to go back to China and do business, but obviously the price is too high for our customer in China, and they said camera can do the same thing. So we actually focus a lot on our EU and Japan and US market instead of other part of the globe. So I would say it's important for you to choose the market that would need your product, even if you have a good concept, you're aiming for the good course. It has to follow what's feasible for that country and that market. The last thing I want to share is that I think if I put a camera in my grandma's bedroom, she would kill me. He would totally kill me. And then that's the same thing for a lot of elderlies. I think we want to care for them, but we also want a way that they would accept to use in daily life. So yeah.
Maybe I can add some as well, since everyone talk about regulation. I think in general, I started the company because I want to do the hard things as well. But then when we met our investors, they say, no, you should not. I mean, you can, but we're just not going to write you a check. So then we think about, okay, maybe we should not just do a lot of the medical grade products, because that would take a lot of certifications and a lot of compliance-driven stuff. So we want to position our product as a typical consumer electronic device, right? So that everyone can use. And a good thing about startup is like you can make mistakes and you can pretend that you're dumb and you don't know stuff. So we go to a meeting room with regulators. They say you cannot do that. I say, oh really? Now I know. So we just drop that right after the meeting. So you ended up doing a lot of service in the beginning and then stream down to a few services that regulators don't. Usually we receive I'm not sure how it works in US, but then we in Hong Kong, we receive a no objection letter. They say something that they're not encouraging you to do that, but they're not telling you that to stop. That to us is a go ahead signal. So we do something like that. So basically that's our approach. We're trying to position our product as a consumer electronic devices, and we try to focus on a very niche market as well, which is sportsmen. So all of our users are athletes, professional athletes, and then we also so that's what we've been focusing on, and then after this we're trying to go to the consumer sports layman in general, whoever likes sports, because that's one thing with sweat as well. It's like the literature papers, like we can find a lot of the literature about blood, but it's when you're trying to find sweat-based biomarker academic paper, it's really hard. So that we have to do a mass market so that we have enough data points so that we can actually make a model. Yeah.
Great. Thank you. The one popular question is about the policy and regulatory approaches as well, but asking, are there any challenges in terms of policy and regulatory approaches in the social implementation of healthcare technology and data? Maybe it's more about social implementation, if you want to add anything more, but otherwise we can also take the other questions, which is not really popular, but I'm interested in this because like you talk about like regulatory thing, but also talk about like ethics, like how people accept the technologies. And the one person say that they are not comfortable with the idea of actually wearing something in the brain, and which is, I think, understandable, like if you are not really familiar with the idea. And yeah, and he or she is asking, how do you deal with patients who have such feelings, or maybe just in general, maybe the acceptance, like how do you raise the acceptance?
So there is, again, I'm going to be specific to oncology and cancer, which is where we are implementing this technology. There is a company called Novacure who develop a wearable device called Optune. This is a device that requires shaving your head every day, or every 2 days, I think it is, and placing basically arrays of adhesive electrodes on the scalp for a minimum of 18 hours per day in order to achieve a modest sort of 4-month survival benefit. This is a very expensive technology. It's around $20,000 a month to be prescribed, essentially, for this. And I think the other thing to remember, so this is already available in market and people are paying for it. They made $600 million in revenue last year for this specific device. And I think that the thing to kind of think about for the immediate applications is that these people have about 14 months to live. That's the diagnosis that they're given. And so, people are wearing this device in order to try and extend their life by 4 months. And if they wore it 24/7, the clinical trial data shows 9 months of survival. So there is a compliance relationship to, if this device could be worn 24/7, they would have a longer life. And so if you had the option to have a device implanted that can do the same technology and monitor your state, that's implanted during surgery that you're already having to remove the tumor, and there's a potential that you can have 9 months or longer survival and not require shaving your head every day and be fully in control of that type of technology at a lower cost, I think there are a number of reasons why you might opt for an implantable over wearable in this particular case when you're talking about something severe as glioblastoma. But I'm sure Em probably has some comments from the wearable space.
I was just a little bit curious, from the audience, who has ever worked with medical devices or medical device regulation or in a medical device company? Okay, just one person in the audience. That's actually very helpful context, because to what Elise said, it didn't make sense to me before we went through regulation, but every time I spoke to a founder in the medical device space, they would always tell me it's about risk-benefit. And I was like, oh, it's about risk-benefit, but I didn't truly get it. And us going through regulation really helped me understand that in medicine and any type of medical solution, it truly is about risk-benefit, like what is it worth to you? So I don't know who's asking that question, and obviously people will always have those concerns when you're looking from a third-person perspective. There's a lot of things that me sitting here today feeling the way that I'm feeling, I'm not willing to do. But if I had 14 months to live, I know that my perspective would very much change, and there would be things that may become acceptable to me or may never become acceptable to me, in which case I just wouldn't be the right patient. So I think in medicine it's just always very important to understand those weighings and in-betweens. And then another thing that I wanted to add is more from the women's health space. There's a lot of things that we consider acceptable or not acceptable just because of what society has taught us. An example is in women's health. A lot of women for contraception use invasive devices like IUDs, which are like essentially insertable devices, or the contraceptive implant, which you put inside of your head, both of which are continuous devices that are inside your body for an extended period of time, not that dissimilar from a brain implant. But for some reason, when it comes to what's actually a much lower, you would say, benefit, which is just a contraceptive benefit, a relatively short term, for many reasons, women have decided that it's worth the cost to them to wear something that could lead to a risk of infections, of traveling to their heart, of killing them, just because it prevents them from having kids. For the vast majority, that is the motivation, sometimes symptom control as well. So for me, when I go back to the fact that like our society has accepted these exchanges for women, but not these exchanges for brain science, even though actually on paper and from a behavioral standpoint, they're actually very similar, I think just shows us a lot of bias in society. And in fact, for me, as someone who works in women's health, I think it also shows that, you know, for women, we're willing to accept a lot more drawbacks than for the quote unquote general population, because we think women will tolerate a lot of side effects. And in fact, if you look at the side effect list on a lot of these devices, that's the case. So all of that to say is I think everything goes back to the risk and benefit, but I do think it's mostly a societal perception and a personal perception problem rather than a technological or biological or regulation problem per se.
That's a good, very nice perspective from the women's health as well. And another reason why I wanted to ask this question is I want to generalize this question because like the ethical issue will be there always, right? Like with the new technologies. So Jack previously mentioned briefly about like lobbying for the regulatory purpose, but do you think like what kind of maybe lobbying or like activities are needed for like overcome these kind of feeling like the less acceptance to the new technologies? Or maybe you can also include about, you know, getting a lot of data because it's like very personal thing, and then getting also from the question that like the data management could be a problem if you have a lot of personal data and have to give to the medical provider. Maybe some people are concerned about those things.
I think when we deal with regulators, I think a lot of time is we need to give them apple-to-apple reference or comparison. So what we did is like they tell, firstly, when we introduce our sweat sensor to the, there's a personal privacy data organization in Hong Kong, and they say it's very sensitive data point because it tells you your a lot of health data, right? Lactate, cortisol, we said a lot. Because potentially what we want to do is like we want to use sweat to replace everything we track with blood. And then they are pretty concerned, but then we give them an example. Like right now, when we are working with an athlete, they are doing blood testing every day as well. So that's data point as well, right? You cannot say, okay, sweat is data point, blood is not a data point. So then we tell them, okay, we go to their database and find out, so how do you store people's blood data right now? And then when I go into their database, they show me an example. Actually, I don't find it's very advanced encryption method. It's pretty standard. It's not a fancy hashing where there's no way to dehash, but then it's just typical standard encryption method. And then we say, okay, what if we apply the same encryption method? But then they say, okay, because you're a sweat, you get a lot more data than blood. So then we just do step by step. Okay, then we apply a more advanced encryption method. How does that sound to you? And then I think a lot of times adding a third party is also a third party, they call it auditor, is also beneficial because it's a neutral, right? So they audit our encryption method, our database and everything, make sure that everything is safe. But then my point is, my experience explaining to regulators is less about you explaining what you do, because if they don't have concern, they don't want to meet you. So when they meet you, they already have concerns. It's easier for you to compare yourself with their existing approach so that okay, it's not so much different. And they have that comfort in mind, then it's easier, yeah.
Does anyone want to add anything?
So I think there's a difference between our product versus other founders' product. I think their product is like medical grade. So you need to go through a lot of certification, regulation before you can provide to the customer or like patient. For us, we are like a device which is mounted in the internal indoor space. So it's not collecting any PII information, and it's also like we are a data provider. We are not like providing very direct analysis on this person is having this disease or issue. Instead, we leave those part of the work to integrators. So at Butler, we're really just building the entry point where you can get health data in a privacy-friendly way. That way, we can get over with a lot of like regulations because we're not defined as a medical device. So that's another thing I think it's a bit different for our company. And normally medical device is taking a long time to get certified and then go to the market, which for startup like ours, I think we need to, have trade-offs if we want to run through that process. So we would rather become like a data provider without like collecting sensitive information from the patient. So that's how we do our business, how we envision the business in our Butler Care, which might be different than very high medical grade products from other companies.
Thank you. It seems there are some people who are interested in startups, like how the startup community environment about healthcare. So one person asking into votes for that, what is your financing and exit strategy for running a healthcare startup? I don't know if it can be like generalizable or like relatable for audience. If you can like add something for that, maybe it would be nice. But like if you don't come up with anything, it would be also not really the focus to talk about a startup environment here. So, but you can continue. Yeah.
I'm happy to talk about it.
Yeah, that's great.
If you want to know.
Yeah.
So the question is about how do you about financing and exit strategy?
Yes.
Yeah.
Exactly.
So I guess for us, we weren't a spin out of the University of Cambridge, but we kind of formed just towards the end of the PhD program. So we went through an accelerator called the Cancer Technology Accelerator, which was supported by Cancer Research UK and Roche Diagnostics and the Medical Research Council. And essentially, the program was designed to try and help you understand how do you build pitch decks, how do you ensure that you have a suitable market, how are you going to run a team, etc. And culminated in a demo day where you pitch to a bunch of investors and people who come and listen. And that was kind of the introduction for me into this whole world. And following that, we started actually pitching venture capital and angel investors for our pre-seed round. These can take on average anywhere from 4 months to a year, depending on what you're trying to raise, how much money you're trying to raise, what your traction is like, and kind of what the milestones that you're intending to hit, and with the availability of the types of investors that you might be really needing to look for. And then we kind of went through that funding round a couple of years ago, and then have been through like another one since then. But in support of that, we also seek non-dilutive funding. So we look for grants that are supported by the government. We've been really lucky to receive some of those from the UK government. And yeah, in terms of exit strategy, I think the question that on what's your exit strategy? Are you going for an IPO? Are you going to try and be acquired, or licensing, whatever else it might be? I think it's really dependent on the situation. It's not that simple to give a single answer to something like that. But how we've sort of positioned ourselves is we've looked at what are other similar similar startups, what kind of journeys have they been through, what kind of exits could we expect or anticipate, and at what stage of development are they? And so we look at a few other companies who have exited, around their Series A, around Series B or C, and whether they're preclinical or whether they have clinical milestones, and that really sort of changes the types of acquisitions that they might have. And looking for typical acquirers, whether you want to go for a medical device type of acquirers, the Medtronics or Bostons of the world, or where you want to look at pharmaceutical companies, so the GSKs, Astellas, these types of companies, where there is track record in both, where acquisitions have happened. And alternatively, you can go the whole way and go to IPO, in which for a medical device company, you would need significant investment in order to market your product and sell it across all of the geographies. So some examples on our end.
On our end, I think the beginning story was a little bit different as well, because we didn't go through an accelerator, which I do think can be helpful for a lot of people, just to understand how this world operates, what types of funding are available, how to build in things exactly. I would say we learned most of that commercial strategy bit, very much like, learn as you go type of perspective. Like, we get feedback on one call and we iterate. So I'd also recommend that, if you have access to an accelerator, it's probably generally a good idea, especially if they don't take a lot of equity. If they do, that's something worth considering. And then if not, there's a lot of things that you can learn by yourself, and I think there's amazing materials online at the moment as well. But then the other thing is, depending on the type of product you're building, ideally build a prototype as early as you can. For something like Soma 1, obviously requires a lot of investment, and probably even building a basic prototype requires a lot of money. For us, we could build a very basic prototype, so we actually had built a prototype prior to raising money, so we could kind of demonstrate what the idea is and how it worked. So essentially, do try to push your product to some level of inflection point so you can show something to investors, and it's likely going to make the process a little bit easier, would be the two main recommendations I have on the actual process. And then in terms of meeting investors, I think I remember myself being an academic and being like, who even is a VC or a venture capitalist, and not knowing how to reach those people. And there's different ways of approaching it, and I'm sure everyone has done different things, but I literally just went through my LinkedIn, which at the moment was very small at the time, and literally found anyone who had the word investor in their profile and messaged them and was like, what type of investor are you? Can you introduce me to investors who are interested in this stage or this thing? And you'd be surprised how willing to help people are, other founders are. I think everyone has been in your shoes at some stage of time, so I just recommend not being scared of asking for help as well. I don't think we could have gotten a fraction of the way as far as we have without the amazing advice and generosity of everyone from the startup community, which is the most generous communities globally that I have ever come across as well. So don't be afraid to ask, because otherwise people don't know how to help you as well. Last bit.
Yeah, for us, I think everyone have a different financing strategy. Even for me, I did a startup before my current startup, and each startup I had a different strategy as well. For this time, I think we are very lucky. One of our co-founders, one of the school professors, so she actually spent 15 years at Cambridge, actually invent that nanotechnology, and got a US patent and Europe patent and all that. So the core IP for us is free, because she's one of our team, and then we actually just got her IP and trying to engineer the product and then trying to commercialize it. And for financing, in the beginning, we got some government grants in Hong Kong. There's a government-owned accelerator program where they give us some cash grants, and then the thing we did is that we actually asked our own co-founder and professor to put our own money in, because we think, okay, If we are not willing to put our own money in, probably our investor will not be interested as well. So that's what we did. We put some of our own money, and then we made a prototype. And then that's where we started our seed round financing, and it went okay because the investors saw that we have our skin in the game as well. And for exit, that's a funny thing because my previous startup, we exited already. So I already have one exit. And my thinking is we never look for any exit. Because I think if you're intentionally trying to look for exit, your deal won't be so good. Because you're trying to selling your baby, right? Like you're going everywhere. I'm here for sale. I'm here for sale. So my thinking is that eventually everyone needs to have an exit, but we just think we should not be looking for an exit. We should just focus on the product build every single day. And then when that potential acquirer come to us, I think probably we're gonna have a better deal, because when they come to you, thinking for M&A perspective, if they come to you, they already have a picture in their mind what they can use your technology for a component of what they already have. I think that's usually they offer you a better price. Yeah, that's just my thinking. Yeah.
So my company is, I guess, a bit later stage than the rest of the founders' companies. So we started like more than 5 years ago, and we raised pre-seed, seed round A and B. So last year we closed Series B. So far we've raised around more than $70 million. I would say, I totally agree with you, Jack, because when a lot of customer comes to us, they would ask me, like, if they want to sign a deal with me, like worth millions of dollars, they're gonna use the technology for years. The first thing they would ask, what's your exit strategy? Are you looking for sale at some point, or do you want to go public? And the thing is, a lot of startups, they sold their company. This is like the original team from the startup got like replaced, and then their vision and company direction changed. So it does not really fit into the original thinking or the deal they made with the customers. Similar for senior living, I think when I go to conferences talking to those caretaker providers, they were like, we're so tired of startups. We want to try new things, but a lot of startups, they come in and we tried their product for 2 years and they got acquired, and then no one is supporting the product anymore. So I think for this, for me, I want to finish what I started and making sure that the product is useful for a long term and helping people in a long term. But I would say when you get to like Series A, Series B, if you're not thinking about exit strategy, you're not a very responsible founder, because you're thinking for the whole company, like other employees around you, like 70 people, what's their way out? But again, I think I try my best to keep the product moving forward in the direction I envisioned, and in the same time, making sure I take responsibility for my people in the company. So.
Thank you. Maybe one more question, which is actually also aligned with what I want to ask. And like there are two questions. Like I can combine two questions. So one is about, like, from business viewpoint, it would be strategical to target wealthy people. But can technology help non-wealthy people as well in business compatible way? So that's one question. So rich and non-rich people. And the other is about being global or local. So whether you think that your company is global or local. But what I want to induce from these is that, like, maybe in 2050, the demographics changes, right? So more European or the Western countries decrease the ratio of the population, and then African or Asian people, like Asian countries, have gained more population, which can affect, of course, the economics. And I wonder how you want to approach those, like, developing areas, and then not necessarily the rich yet, but like growing towards 2050. So does anyone want to take that? Maybe think about it? So not necessarily. So either you focus on the the rich people, like wealthy people, or non-wealthy people, or you can also focus on the regional differences that you think would be nice to do. Please.
I can try to comment on some parts of what you've asked, but I think there's like a lot of barriers around access to technologies, and that can be demographically related, but also where are you located, how far are you from the nearest hospital, and so there's a lot of things from a policy point of view and from a government point of view that kind of are going to maybe dominate the outcomes there. But I also think, especially for a technology like ours, where we're talking about implanting devices, I think cost comes as the biggest barrier at the moment. And so to manufacture these types of devices today at the scale that you would need to, for a lot of people to access them, it can be quite high, and therefore, there's getting the devices into the patient, there's reimbursement strategies, and then the cost to the person at the end, depending on which country you're at, whether it's private or public. And so in order to make sure that there is a return there, then the markup does go up quite a lot today. What we're hopeful for, especially in the way that we're designing the technology that we're making, is to try and move towards wafer scale manufacturing. So adopting a lot of the techniques that people use to make chips and implementing those into our product. And so one aspect of that is the part that actually interfaces the brain for us is using thin film manufacturing methods. And so rather than making one device in a batch, in a single wafer, you can make hundreds of devices in those batches. And so what we're looking at and how we're trying to also protect is how do we implement those types of manufacturing methods into the rest of our assembly in our device? For two reasons. One, it reduces the time to build them, but it significantly reduces the cost, and therefore you can market the device for significantly less. And we hope that that's one element that we can support access for, from a cost point of view. The other part for us is around the remote monitoring aspect. So if someone has this device, rather than coming to hospital every however often for their to get an MRI or to have treatment, it can be done from home. And so it's reducing that barrier to have to get to hospital, which is a massive barrier. A lot of these people are very, very sick. So, those are some of the ways that we're trying to increase access from our product.
I'll comment maybe a little bit broader first, and then can speak a little bit about how we're working on the access point. But I mentioned earlier that I worked as an emergency medic, so obviously seeing a lot of the front lines, but I also spent some time working in public health, specifically on behalf of the UK government, looking at what they can invest in to make the UK healthier at the time. And I remember at the time we were looking at a couple of areas, so primarily mental health, sexual health, and childhood and teenager well-being. And I remember at the time we had this big budget to spend, like they really wanted to reduce the childhood obesity problem, reduce the transmission of sexually transmitted diseases in the UK, and they wanted to improve mental health, specifically depression in the UK, had big budgets, and they found nothing to invest in because they're like, there's actually not been much innovation in the space. Like essentially all of the methods that we use in these fields, so mental health, childhood care, sexual care as well, have just been very old and there's nothing to invest in. So when I went into technology development, one thing that was front of mind is that a lot of people speak about access as, something that innovators should think about. And obviously we should think about it from the perspective of cost, from the perspective of innovation. But I've also seen the perspective that unless we are really pushing to innovate, even if our technologies are initially accessible by very few, at least we open up options that when those budgets are available, they can be opened up more broadly as well. Because I remember sitting in that room and knowing we have the money, but not enough innovation to invest it in is also a problem, as is, kind of having innovation that cannot be scalable. So I guess that's the broader comment, that as a technologist and like as an innovator in the space, I really think that we should try to innovate as accessibly as we can, but we should still try to innovate even if we think that at the moment our technology can even reach a few, because as Elise said, manufacturing methods might change, other circumstances might change, payment methods might change, which will transform it, but technology development will take time, and budgets are on average easier to solve than technological problems. On our specific case, I think I'll just double down on something that Elise said. For us, having an at-home treatment is absolutely paramount. I think that in in the end, like all technology that relies on a clinician, transportation, your doctor speaking a certain language that you can't interact with in a comfortable way is always going to be a barrier in healthcare, and all the healthcare that can be accessed in a comfortable and ideally at-home setting and with AI, maybe translated in your own language, speaking to you in a tone that you respect, someone you trust, maybe your best friend or whatever, I think will create a better healthcare experience and hopefully long-term make people less scared about technological interventions, which I think oftentimes the scariness is also part of the way that we interact with the healthcare system, separate from those technologies as well.
Yeah, I think in general, a good technology should be accessible to as much as people as possible. But then I think a lot of time, just business-wise, it's a chicken and egg problem because just as a hardware company in the beginning, it's really hard to make the device cheap when you only make 50 units. It's just nearly impossible. Even that we are actually located in Hong Kong, which is very close by to Shenzhen, which is very in China. It's a very famous place for all the manufacturing activities happening. But when you go to a manufacturer, you say you want to manufacture a POC prototype, and then only 50 units, it's just nearly impossible to make it very cheap. So that's why in the beginning, the early adopters are usually the group of users who are willing to pay at a premium price. I think it just happens to every technology. But then as time goes by, as we making, to me, it's just when I make bigger volume, the price will just automatically go down, and eventually we'll be able to serve. I don't want to categorize as a developed country or a developing country. I just want to say we want to serve as much people as possible. Because even in a developed country that they are wealthier, maybe financially speaking, they're also looking for cheaper alternative, right? It's like if I'm rich, I just want to buy cheaper goods with similar features. That's what I mean. So eventually we want to make the product as affordable as we can, yeah.
Thanks. You want to make some point?
Yeah, I think every founder, they want to make their product affordable and accessible to everyone. It's not only because you want to provide the technology to more people, but also you want like a very good competitive strength, like advantage over your competitor's product. If you have lower cost, it's obviously you'll have more traction. But the fact is, a lot of startups doing like innovations, it's very hard for them to make their product profitable in the first few years, and they rely on capitals or investors to build prototypes, sell to the initial early adopters or people who are willing to, or you are willing to sell less priced, but getting more customer to try your product. So you might look at, this company raised millions of dollars this month, but a lot of money spent in R&D, and it's not like cost on the hardware only, but also like software, computational, cloud service, and a lot of other things. So I would say yes, eventually everyone wants to make it affordable, but it's a pretty hard journey for innovation, and especially hardware-related company. But our vision is to put our sensor in every single building eventually, and very easy to install and operate with. That's a long-term goal.
Yeah, great. Thank you everyone for the discussions. I think we are already out of time. And now we want to close the session. So please thank all the panelists today. And thank you all for joining. And then thank you for listening and also asking questions. And I'm sorry for the shortage of time so that we didn't really get to ask all the questions. But thank you.